Hello, welcome back to school, 2013, and here we go. Our first lesson is on whole numbers. Now, what you're going to be learning is that you will define, identify, and compare whole numbers. So, let's build our vocabulary here. The numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on, are referred to as the counting numbers. Now, when the number 0, and yes, 0 is a number, when the number 0 is added to this list, the numbers can be referred to as the set of whole numbers. Now, I remember this by, if we look at the word whole, let's look at the word whole. The word whole has an O in it. Now that O looks a whole lot like our lovely friend over here, 0. So we remember that whole numbers with that O, or 0, are all the numbers from 0 to whatever we can count. All the numbers to basically 100, a million, a billion, so on and so forth. Now these are, remember, counting numbers, including 0. How we remember that is that whole number. Now we're going to identify some of these whole numbers. Identify the whole numbers in the set 3.4, 3 over 2, or 3 halves, 42, and negative 2. Now 3.4 is a decimal. It is not a whole number. It is not a whole number. 3 over 4, oh, they have a typo. 3 over 2 over here, 3 over 4 over here. 3 over 4 is a fraction. It is also not a whole number. 42, is it a whole number? Yeah, definitely. 42 is a whole number. Is a whole number. Now we have our lovely negative numbers here. Now negative 2, is a negative number a whole number? No, it's not. So remember, our whole numbers are 0 to whatever, in the positive direction. So basically we can put up here positive. We want a positive number. So negative 2 is not a whole number. So what do they want us to put here? So 42 is the only whole number in this set out of 3.4, 3 over 2, 42, and negative 2. Alright, your turn. Identify the whole numbers in this set 5 over 8, or 5/8, 14, and 3.7. So we can look back. 5 over 8 is a fraction. It's not a whole number. Not 5 over 8. 14, it's positive. It's, above 0. It's a counting number, not a decimal. So 14, yes, is a whole number. 3.7, 3.7 is a decimal, not a whole number. 14 is the whole number. Now we want to compare. We're comparing whole numbers. We have 15 and 16. We're going to replace this blank circle here with symbols. Remember these symbols. This one is greater than. This one is less than. We'll put a G here for greater and an L here for less. Oh, you can't see any of this. There we go. Put a G here for greater, L here for less. Or we want to put an equal to sign to make the statement true. Now, 15, they give us a number line right here. 15, is that greater than, less than, or equal to 16? Well, we can see here that 15 is below 16, so 15 therefore is less than 16. And here we can fill this part. 15 is less than, and remember than has an A, not then. less than 16. 15 is less than 16. Let me turn our page. Up here at the top it says your turn. Replace that circle there with one of the symbols. Again, it has greater than, less than, or equal to make it a true statement. So, pause me here, see if you can do it on your own. Alright, let's see if you got the correct answer. Now 9, we have 9 on the number line. 9 would be somewhere around here. Maybe if we went down, we have 8, 7, 6, 5, 4, 3, 2, 1. We have 9, and we have 3. Where are we getting those numbers? Right here, 9 and 3. So let's see. Is 9 greater than, less than, or equal to 3? Well, we can see here that if it's farther along on the number line, it must be greater than. Let's put in that greater than sign. Now, here we want to order the whole numbers. So not only are we comparing their whole numbers now, we want to order them from the least to the greatest. So, we know, again, here we've given our number line, 18, 14, and 15. We have 18 graphed here, we have 14 graphed here, and we have 15 graphed right here. So we can see which one's the least number. Well, the least number is just the one that's over to the left the farthest. Over to the left. Think least, left. So the least number is going to be 14. 14. Now the greatest number is the one that's over to the right. You can think great to the right. So the greatest is going to be here. It's the farthest over to the right. We're going to put that 18 right here. So the numbers in order from least to greatest are, we can say 14, that middle number there, 15, and our greatest number there, 18. So your turn, we want to order the numbers 12, 9, and 11 from least to greatest. So go ahead and pause me here and see if you get the right answer. Alright, so if we put these on the number line, we'll make another number line here. Let's start with 5. We can go 5, 6, 7, 8, 9, there's one of our numbers. 10, 11, there's another one of our numbers. 12, there's another one of our numbers. We can stop there. So we want the least number. Remember, least left. So what's the one that's farthest to the left? We have that 9 right there. So we're going to put 9 first. 9 is the least. Now we want our greatest number. Greatest is going to be which is farthest over to the right. Great, right, that R sound. Here we have our 12 that's farthest over to the right. So our middle number just goes in the middle, and that's going to be our 11. So, in order from least to greatest, we have a 9, 11, and 12. So, now that we've done that, we've ordered our numbers 9, 11, and 12. Let's review what we've done. We've reviewed how to order or compare whole numbers. Now remember, the definition that we gave for whole numbers is back here on page 5. Whole numbers are our counting numbers, or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all the way up. But remember, we include that number 0. The way we can think of that is whole has this O, kind of looks like a 0. We can remember it that way. Whole numbers include 0, and they go in the positive direction. They're all whole, meaning can't have decimals, can't have fractions, can have the number 42 or numbers like 42, cannot have negatives. So, thank you for watching this lesson on whole numbers.